Before we go on and talk about light, there was one more thing I wanted to talk about with the absolute magnitudes. We had the equation for absolute magnitude. The absolute magnitude is the apparent magnitude plus 5 minus 5 log d. And so we did a couple of examples with this. Well, suppose you somehow knew the absolute magnitude of something. For example, certain stars have a known absolute magnitude. Certain galaxies have a known absolute magnitude. And then you look at it and see how bright does it appear. Well, everything else in the equation is known except for d, which means you can do some math and solve for d. And if you do the math, you get this equation right here. And so it's d equals 10 raised to the apparent magnitude minus absolute magnitude plus 5 divided by 5. So all of this is the exponent. So this is the numerator, that's the denominator. So this is 10 to the m minus m plus 5, all that over 5. This is not multiplication. This is an exponent. And so let's do an example here. So let's say that you have a star, and it's a particular type of star, and you know that this type of star has an absolute magnitude of minus 2.51. But from our perspective at Earth, we see the star, and the star has a magnitude of maybe 16.3. Okay, so it's very far away. So it looks very, very dim. And I want to know how far away is it. Now, the problem is that if a star is so far away that you cannot measure parallax accurately, you cannot use the distance formula. So you have to have some other way of finding distance. And the way we do that is this, we call the distance modulus formula. And so here we have it. So in this case, d equals 10 raised to the exponent, and the exponent is 16.3 minus a negative 2.51 plus 5 divided by 5. Now you have to be careful how you enter this in the calculator. You need to have parentheses around here. If you don't have parentheses around the numerator, then what happens is instead of having everything in the numerator divide by 5, you just have 5 over 5. So you have to use the proper calculator order of operation. Okay, so 16.3 minus a negative, so that's plus 2.51 plus 5. And so this becomes 10 raised to the numerator is 23.81 over 5. Okay, so that's 10. So 23.81 divided by 5 is 4.762. And so 10 raised to that quantity, so 10 raised to that quantity, it turns out to be 57,800 parsecs. The answer always comes out in parsecs. If you want this to be something other than parsecs, for example, if you want it to be light years, you'd have to multiply that answer by 3.26 in order to make it light years. But this is how you use the distance modulus formula. We can do one more example. Okay, so again, we have something here, and we know that it has an absolute magnitude of maybe 1.61, and it has an apparent magnitude. So from Earth, we look at it, and it has an apparent magnitude of 9.45. And so I want to know how far away is it. So again, the distance modulus formula. So 10 raised to the m minus big M plus 5 over 5. Okay, so that's going to be 10 raised to the exponent, and the exponent in this case is going to be 9.45 minus 1.61 plus 5 over 5. And again, if you enter this into your calculator, okay, you can do that, but you have to make sure that you enter it correctly. Okay, so 9.45 minus 1.61 plus 5, all of that stuff divided by 5. So this is going to be 10 raised to the 2.568 power. Okay, so that's going to be equal to 370 parsecs. Okay, so once again, we got 370 parsecs. Okay, so that means that if you multiply by 3.26, that's going to be about 1,200 light years. Okay. Now, this is how you do it. Now, what you need to do is you need to practice entering into your calculator these numbers to get those answers. Make sure you know what order to press the buttons in your calculator, because different calculators are a little bit different as to how they handle these things. So you need practice making sure you know which order your calculator uses to press the buttons in order to get that. You might need to look in the instructions for your particular model calculator in order to figure out what instruction, what order you have to do to get those answers, because you want to make sure that you get the right answer, because the lab that you're going to be doing is going to be using this. So with that kind of includes everything until we get ready to start talking about light.